The purpose of this video is to demonstrate how you could create a random number array that is missing a certain set of values, say between 0.2 and 0.3, from a white noise generator and a for loop. It's the complement of the video where you're creating the same sort of array using a while loop and the pair of dice. So as before, we will begin by creating a new virtual instrument, and let's take and move the front panel and the block diagrams so that we can operate on them with relative ease. The first thing that we want to do is generate our array of random numbers that we're going to do some sorting on. So as we have in the past, we will go to look at signal processing. Signal generation looks like a good one. Uniform white noise looks like a very good one to use. And so if we read the manual again, this generates something that goes from minus amplitude to plus amplitude. We want something that goes from 0 to 1. So what that range is from minus 0.5 to plus 0.5. Let's go ahead and create a constant here, 0.5. And now we need to do something with that. Once we've generated that, we need to shift it up by 0.5. So let's take and add our 0.5 to everything. So there, I've added it, and we will connect that, if we can find it, to our array. So there we're generating the array of a given length. Now, previously, when we did this, we specified the exact length of the array that we wanted. Here we know we're going to have to throw some values away, so maybe we want to have some sort of multiplicative factor to make sure that we have enough of them. You can get very fancy with the formulas to calculate this. I'm going to make it fairly simple. We are going to simply multiply the number of samples that we need by 1.5, and so I will put a 1.5 here. Depending on the length, that may or may not be good enough. And so here's the number of samples. We'll connect it in there, and you'll notice that this is all orange. If we wanted, we could make some of those integers, because that's expecting integers, but it creates the little orange dot there. Okay, so now if we're going to do this, we need to put in the array size. So we'll call this array size. And since the array size actually should be an integer, we can actually right-click on there and go look at the representation. The thing that we're probably interested in is an I32, which is an integer that uses 32 bits. We could go I64 if we wanted really long array sizes, but that will probably work just fine. Okay, so now when we enter our array size, and let's go ahead and put a default array size of 100 in there, and make that our current value default. We are now creating an array that has been shifted. Just for fun, let's go ahead and take a look at that and see what it looks like. So we will create an indicator, and we will look and see if it indeed is an array, and all of them appear to be in the range of 0 to 1. So far so good. Okay, get rid of the bad wire there. So now, as we did before, we want to go through and sort out the array and divide it into two categories, those things that belong and those things that don't belong. But this time we're going to use a for loop. For loops have a property known as indexing, in that they will, if you don't put a value for n, but you put an array into them like we're going to do here, it will operate each on each array value in turn See if we can convince it. That did not work very well. So let's undo that and try that again. We want to go from here and connect right to the edge of the thing there. Notice that we have the hollow tube there. So what it does is it operates on each element of the array in turn and operates until the array is finished. As before, we will do ourselves a case structure, and we'll put that in here. On the true case, we just want the element to go through without any sort of problem. In the false case, we will want it to go through and have something happen with it. So again, I'm going to put a shift register on here because we have problems if we do it pretty much any other way. So if it's true, we just want it to go straight through. If it's false, we are going to want to build our array and add the species on there. Again, you could do this with ORs and reverse the true and false. I again am going to create an initialization constant for this thing with an array, and then since I want it to be a numeric array, I will put a blank numeric in there, and that will make this somewhat happy. So we will say if it's false, we want to append something to it. If it's true, we want it to just go straight through. And this thing is a little bit unhappy at the moment, but what we want it to do is append the value that's coming from here. So if we click over here and put that through on that, now everybody is happy. All of the bad lines have gone away, and you can see that we are appending an element onto our array each loop. So now, as before, we need a condition on this, and we want our condition to depend on whether the thing is in range or not. So we can, as we did before, get a couple of comparisons. We'll get a greater than and a less than. And we'll be annoyed by the stupid wires that auto-connect. Get rid of those. And then we will put an AND Boolean there to put the two of those together. And we have to think through the logic of how we're going to do this. But since we already did that on the earlier video, we will just do it this way. We'll connect the lower bound on the greater than. Actually, before we do that, let's go ahead and connect our input value here. And let's clean that wire up. Okay, so then we will create a control here that we are going to call lower bound. Not bound, and we will create another control that we're going to call upper bound. Okay, so this will go through and sort the things out. It's looking a little messy, so I'm going to do the Control U on it and see if we can make it look a little neater. Okay, there we've got our lower bound, upper bound, the true and false conditions, and we end up with our array at the end. Now, the thing that we want to do is we want our array to have an exact size. So what we're going to do is take an array subset. And here's the array subset. And if we connect the array subset to our output here, it has two indicators, or two controls. One is the length and the other is the index. The default index is 0 starting from the beginning, and so here we'll be able to attach the length. And so now we've got enough samples that we should be able to get everything. And as before, we can put on from the mathematics, probability and statistics, we can put in the standard deviation, other things, and also do the RMS values on that. It's actually fairly straightforward to calculate what the expected value should be for the mean, the standard deviation, and the RMS for these, and it's probably worth going through the exercise to make sure that your thing is working properly. Create indicator and one last indicator. There we go. We could always make this fancier as we've discussed before, but let's see if it works. Again, the upper bound was 0.3. The lower bound was 0.2. And it does seem to not be working terribly well, but let's put in something a little higher, like 1,000,000, and see how that does. And on that, yes, it's achieving the expected mean just about every time. So again, to recapitulate, what we've done is we have created an array that is long enough so that we can throw away a bunch of samples and still have our desired array length. We then used the automatic indexing on the for loop to look at each array value in turn. If it is in the range that we're excluding, then we don't include it in our final array. If it is in outside that range, then we do add it to our final array using this case structure and the greater than and less than and block. And then we take and only use enough of our array, which should actually be longer than necessary, so that we get the desired length, and then we have the values there. Perhaps not as efficient as the other loop, but it works just fine.